Okay, guys, we're going to take a look at number 10 here. Um, so, number 10 says this is a word problem. Dana cuts her arm and gets a bacterial infection. At the moment of infection, there are 5,000 bacteria in the wound. The bacteria double every hour. So, it wants us to write a function that models the number of bacteria after the number of hours. So, for this first part, first we should notice that this is going to be an exponential growth function. Um, so, we're going to have f of x. Now remember, for exponential growth, we want to do our starting point, and then we multiply, because it's a multiplying pattern. We multiply by our growth rate raised to the x power. So our starting point here is going to be this $5,000, or excuse me, 5,000 bacteria. So we start off with 5,000, and then we're going to multiply, and we need to find the rate in here. Now the rate, I'm seeing this word double, and to double means we're going to multiply it by 2. So I've got 5,000 times 2, and then I'll go raised to the x. So that's my function. F of x equals 5,000 times 2 raised to the x. Now it wants me to use my equation to determine how many bacteria are left in the wound after 7 hours. So what I'm going to do is I'm going to evaluate this upper equation here, okay, this top equation. I'm going to evaluate it for when x equals 7 hours. So we write that down as f of 7 for 7 hours equals 5,000 times 2 to the 7th, because x becomes 7. Okay, let's see. I'm going to do it on my calculator real quick. So I've got 2 times 2 times 2, that's 3, 4, 5, 6, 7. So I've got 128 times 5,000. So it's going to be 5,000 times 128. That's 2 to the 7th. I'm going to multiply those together, and I get 640,000, and these are bacteria. Okay, so there we go. There's a word problem with an exponential growth function.